Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a reactive power control. In that, the subtopic is flexible AC transmission system, that is FACS devices. Now as the power transfer goes, the power system becomes increasingly more and more complex to operate, and the system can become less secure for riding through the major outages. It may lead to the large power flows with inadequate control, excessive reactive power in various parts of the system, large dynamic swings between different parts of the system, and therefore the full potential of a transmission interconnection cannot be utilized. With the increased loading of the long transmission lines, the problem of transient stability after a major fault can become a transmission power limiting factor, and that's why the idea of a so-called flexible AC transmission system, that is FACS, was introduced in 1980s by Electric Power Research Institute, that is EPRI. The FACS is the concept which is based on power electronic controllers, which enhances the value of a transmission network by increasing the use of their capacity. Now, as these controllers operate very fast, they enlarge the safe operating limits of the transmission system without having any risk, and it improves the stability. FACS devices are used for a dynamic control of the voltage, impedance and the phase angle of a high voltage AC line. So that's why we can define a FACS as a FACT is defined by the IEEE as a power electronic based system and other static equipment that provide a control of one or more AC transmission system parameters. Now why it is used? It is used to enhance the controllability and increase the power transfer capability. Now let's discuss about objective of the FACS devices. First is nothing but control the power so that it flows on the desired routes. Now power may be controlled by applying a voltage in the midpoint or by applying a voltage in series with the line and in a phase quadrature with the current flow, or by regulating the magnitude of sending and receiving end voltages. Now this is more effective than the previous techniques. Then second important is nothing but increase the loading capacity of the transmission line. Now it is not possible always to reconstruct the transmission lines. So that's why we are trying to improve the loading capacity through the existing infrastructure. And third one is nothing but prevention of a cascading outages by contributing to the emergency control. Last point of objective of the FACS technology is improve the generation productivity. Now let's discuss some benefits of the FACS technologies. The first point is nothing but the cost. Now due to high capital cost of transmission plant, the cost considerations frequently overweight all other considerations. Compared to the alternative methods of solving transmission loading problems, FACS technology is often the most economical alternative. As we discussed earlier, it is not possible always to construct a new transmission plants. So we can improve the power transfer capability of the line just by implementing the FACS devices. Second one is nothing but the convenience. Now we know all the FACS controllers can be retrofitted to existing AC transmission plant with varying degree of ease. If we compare to the high voltage direct current or 6-phase transmission schemes, solutions can be provided without a wide scale system disruption and within a reasonable time scale. Third important benefit is nothing but an environmental impact. In order to provide a new transmission routes to supply an ever increasing worldwide demand for an electrical power, it is necessary to acquire the right to convey electrical energy over a given route. Now what we have to do, we have to purchase some land. Now it is again very difficult purchasing of the land. There will be a right of the way. So it is common for an environmental opposition to frustrate the attempts to establish a new transmission routes. Therefore, FACS technology allows a greater throughput over existing routes and hence the meeting consumer demand without the construction of new transmission lines. This is what is the advantage or benefit of the FACS device. And the last important point is nothing but increased transmission system reliability and availability. Now let's have a discussion about classification of the FACS devices. Devices or fax technology is categorized into four important points. First one is the series controller, second is the shunt controller, third one is a combined series controller, and fourth one is a combined series shunt controller. So let's have a discussion about first controller, which is nothing but a series controller. Now a series controller, what it will do? It is basically a variable reactive or the capacitive impedance whose value is adjusted to damp the various oscillations that can take place in the system. This is what is the diagram here shown of a series controller. What it does, it injects voltage into the system. So therefore, it is achieved by injecting an appropriate voltage phasor which is in series with the line, and this voltage phasor can be viewed as a voltage across impedance in a series with the line. Whatever voltage which is injected with the help of series controller, that injected voltage is in phase quadrature with the line current. Now what is the meaning of phase quadrature? Phase quadrature is nothing but angle between voltage and the current is 90 degrees. So let's say, suppose voltage V is on x-axis and this will be your current I which is on y-axis. So angle between these is nothing but a 90 degree, which is called as a phase quadrature. Now as the angle is 90 degree, we know that what is the formula of active power? P equal to VI into cos phi. What is the formula of reactive power? Q equal to VI into sin phi. Just put the angle phi equal to 90 degree. When we put here phi equal to 90 degree in first equation, what you will get? You will get P equal to 0. And when you put here phi equal to 90 degree in second expression, then what you will get? Sin 90 will be 1. So you will get answer as Q equal to V into I. So therefore, this series controller only deals with a Q. The examples of such controllers are static synchronous series compensator, SSSC, then thyristor switch series capacitor, TSSC, and thyristor controlled series reactor, that is TCSR. So this is about a series controller. Let's have a look for the second type of controller, which is a shunt controller. If you see, the construction wise both are same, but what it injects, the thing is different here. In case of shunt controller, it injects current into the system at point where they are connected. So how it injects? Similarly, it injects the current which is in phase quadrature with the line voltage. So angle between whatever current and the voltage here, it is again 90 degree. So again it deals with your reactive power, that is Q. So examples of this is nothing but STATCOM, that is static compensator, static var compensator, SVC, and fixed capacitor thyristor controlled reactor, that is FCTCR. So how it is connected? If you see, this is what is connected or it is shunted to the line. That's why it is a shunt controller, and it injects current into the system. Third one is nothing but combined series controller. Now there are two configurations, or we can say two combinations in the combined series controller. One configuration consists of series controllers which are operating in a coordinated manner in a multi-line transmission system. Now what is the meaning of coordinated manner? Means same control technique or same controller is utilized for the operation of both series controllers. The other configuration, it will provide independent reactive power control for each line of the multi-line transmission system, and at the same time it facilitates the real power transfer through the power loop. So an example of this type of the controller is interline power flow controller, IPFC, which helps in balancing both the real and the reactive power flows on the line. So this is what is the diagram of combined series controller. So if you see, it injects voltage only, and this is also it injects voltage only, which is in series with the line. The last point is nothing but combined series shunt controller. Now again it may have two configurations. One being two separate series and shunt controllers that operate in a coordinated manner, that is same control technique is utilized here, or other one is being an interconnected series and the shunt component. So in each configuration, the shunt component injects the current into the system that we already discussed earlier, and the series component will inject voltage into the system. So when these two elements are unified, what it will do, a real power can be exchanged between them via a power link. Now the examples of a series shunt controller are unified power flow controller, that is UPFC, and thyristor controlled phase shifting transformer, that is TCPST. Now this makes a use of advantages of both the series and the shunt controllers, and therefore it facilitates the effectiveness and independent power or the current flow and line voltage control. So this is what is the diagram. This is a coordinated control, means same control algorithm is utilized for injecting voltage through series controller and injecting current through shunt controller. And here there will be a same DC power link is connected. So this is about basics of the fax devices, its objectives, then benefits or advantage, and classification of fax devices. Thank you for watching this video.